Now let's move on to the next tool provided by STAM on risk assessment. Hello, Davide.
Hi, hello, good afternoon to everybody. So I'm gonna share my screen. Perfect. So again, good afternoon to everybody. I am Davide Ottonello. I'm working as project manager at STAM, and I'm basically mainly working in the security division of the company, and specifically I'm responsible for all the research and development project which deals with the risk assessment. So today I'm gonna presenting to you what we have done in InfraStress. So we have developed a web-based application which is dedicated to industrial plants, and that it is capable to carry out a quantitative risk assessment of the critical infrastructure. So I will have a very short introduction with slides, and then I'm gonna show you a live demo of the tool. So before talking specifically about the tool developed on within InfraStress project, I would like just to say a few words about the background of STAM in the risk assessment fields. So we are basically developing risk management applications since 2010. We have developed this application both in some research and development projects like InfraStress, but also in other industrial projects with our customers. And we have basically implemented the solution in 4 domains. So the industry, which is basically let's say an over level domain of InfraStress, the railways, the airports, and the sub-target intended and public spaces such as shopping malls, squares, and so on. So and the right side of the screen, you can see some screenshot of our application. And of course, we started with some rough technology, such as tools developed in MATLAB. And then we announced in parallel both the methodology underlying these tools, but also let's say the IT aspect. So we are basically delivering now web applications. Talking about specifically the tool developed for the InfraStress project, which is called with the code STAP1.2, because this is a software application which basically contributes to enhancing the security and the resilience of the industrial plants. You can see basically the initial requirements that we have drafted in order to be sure that at the end we will have developed something that could be useful for the project and for the pilot, of course. So, of course, the first requirement was to develop a tool which was capable to evaluate both the risk and the vulnerability, and which was basically dedicated to the industrial plants, and of course taking account their main features. Then we have a dedicated focus on physical attacks, so basically terrorism and crimes, and this was due by the fact that there are other tools which face risk assessment towards, for example, cyber security and natural hazards within the project. So we decided to specifically focus on this kind of threats. Then we were asked to develop something that should be applicable and testable in different pilots. So basically something agnostic to pilots, and after we can see how we can let's say deal with this aspect. And finally, of course, we should have something that can be integrated within the whole InfraStress framework. And of course, we should have something that is capable to communicate with the external world. Starting from this requirement, we have defined the main features of our risk assessment application. As I said before, we have developed a web-based application in order to facilitate the continuous delivery and also the continuous improvement of this application. Then we should have something customizable because, as I said in previous slide, we should be able to carry out this risk assessment in different pilots with their own peculiarities. Then we have developed something automatic, so we can say that in some way the risk assessment procedure is automatic because once the user has entered the required input into the tool, it should not intervene anymore in the computation project. So in something that could facilitate the user experience and also speed up the whole process. And finally, I think one of the main important features, we have developed something which is capable to carry out quantitative risk analysis. So basically the results of the risk assessment is expressed as numerical and quantifiable outputs. This is a very, very rough scheme of the methodology and the functionalities of the application. In few words, we can say that we have, of course, a set of inputs that comes both from historical data. For example, we analyzed the global terrorist database, which is one of the most comprehensive databases containing lots of records about physical attacks in different domains, while some other inputs are coming from the users, especially those inputs which regard the characteristics and the figures of the infrastructures. Then our computation engine is basically capable to generate a lot of scenarios according, for example, to the target, to the type of attack, to the time slot in which this attack occurs, and so on. After that, we have, of course, the countermeasures that are capable in some way to prevent, detect, or mitigate these attacks. And of course, these countermeasures can generate different outcomes. So the same scenarios, according to the countermeasure, can have several outcomes. And after that, we have two dedicated computation engines, one for the likelihood, another one for the calculation of the impact. And of course, from that algorithms, we are able to compute, of course, the risk level expressed as euro per year, the number of casualties, the number of injuries, the extent of the physical damage to the infrastructure, the economic losses, and so on. And all these outputs are shown in a specific dashboard that we will see in a while, and can be also exported as a sort of report. So now I'm gonna briefly show you the tool as a live demo. Okay, so now you will be able to see the home of the tool. In this home, you can basically see two main elements. The first is the baseline, which is basically represents the industrial plant in its standard condition. So this is the main element that the user could modify and customize according to the different characteristic of its own plant. And then we will see how it is possible to edit this plant. And then we have other elements which are called configuration that basically represent the same plant, but in some conditions that are different from the standard one. So for example, in this demo, I've created two configurations. One which represent a sort of minimum protection level, and another one in which I've, of course, announced the number of the power of countermeasures, which have called the maximum protection. But you can basically create several configurations. For example, if you have, I don't know, extraordinary maintenance work within the facility, so something change, maybe some countermeasures are off, or maybe there are a lot of external people within the plants, and so on. So this is the idea. So you have one main element which you can take as a reference, which is the baseline, and then several configurations that you can basically create with a simple click here. Of course, starting from the baseline. See in details how the plant can be edited. We have this main screen in which you can basically here enter some basic information of the plants, such as the country in which is located and a number of employees. Then on the left, you can find some libraries. For example, here we have the libraries corresponding to the security measures. So if you want to add a security measure to your own plant, of course it is present, you should just take the countermeasure from these libraries and add it in this blue box. And in this way, you have this countermeasure effective on your own plant. Then, for what concerns the modeling of the different spaces of the infrastructure, we have another element which is called areas. As you can see here, I've already modeled some areas. If you want to create a new area, you just take the element from the libraries, and again, you can drop it in the blue box, and you can basically create a new area. Of course, you can go into the details for modeling the areas. So, for example, taking this an example, we can see that also for the areas, you should enter some data, for example, the size, the economic value expressed as euros per square meter. Then you can check if there are some hazardous substances within this area. Then you can, for example, tune the number of people which are present in the area during the different time slots of the day. That is, of course, a crucial parameter to estimate the potential impact of physical attacks in this area. Then again, you can add some security measures, and this time the security measures will be added only to these single areas, so it will be effective only in physical threats occurring in this area. And then finally, we have the last element, which is the asset, which basically represents any device and equipment which is needed within the plant to basically carry out the operations and the business. And also in this case, you can take the element from here. You can add the as element, enter, for example, the name, the economic value, and if there are some active security measures, and you can add also the asset. So this is basically how we can model different plants. Then we can save, we can come back to the home, and let's see how to run the risk analysis. It is very simple. We just can choose a configuration, click on this button, and you can see appearing the dashboard containing the results of the risk analysis carried out considering this configuration. So we have different charts basically expressing the result of risk analysis, for example, the annual risk level, broken down according to the threat which is modeled, such as explosive attack, sabotage of equipment, arson attack, and so on. And at the same, you can see some indicators about vulnerability. You can see how the risk change within the different time slot of the day in the daily risk profile. You can see the loss exceedance curve that, as you probably know, it is a very important input to estimate the likelihood of having a certain impact, a certain, let's say, expected loss. And then we have another dashboard, which basically represents the spatial distribution of the risk within the infrastructure. So for each area that we have modeled, we can see basically some indicators such as the risk level, the vulnerability index, and we have a sort of chromatic scale in order to identify at a glance which are the most risky areas within the infrastructure. Last but not least, we can finally export what I usually call the risk register. So let's see in detail what is this risk register. So as I said before, our tool is generating several scenarios. And basically, this risk register contains all these scenarios generated by our tool. For example, in this case, we have generated more than 12,000 scenarios. And then for each scenario, we can see that we have basically these parameters. So we have the coordinate of the scenario, so the attack type, the magnitude of the attack, the target, for example, in this case, the server room area, the asset target, the time slot in which this attack occurs, and the outcome type. So as I said before, according to countermeasure, we can have different outcomes. So basically we have prevented outcome, diffused, mitigated, and not mitigated. Then for all of these scenarios, we are basically calculating the following results. So we have the likelihood of occurrence of these scenarios, the average number of fatalities, the average number of injured. Of course, these results take in account how many people are in that areas during the time slot in which the attack is occurred. Then we have a sort of indicator expressing the physical damage to the infrastructure. And then we have the economic losses, which derives from fatalities, injuries, and physical damage. And finally, we have the risk level for each of these scenarios. Of course, you can see that the risk level is of a single scenario is very low. But of course, if you, in the end, sum all of these 12,000 scenarios, you can see that you have a not negligible risk level, as shown before in the risk dashboard here. So just to conclude, I come to my last slide of the presentation. Can you still see the presentation? I think so. So basically, the last slide is dedicated to the integration of this tool with the InfraStress platform. So basically, we together with the other partners, we decided to have a unique entry point in order to help the user to enter into the different risk assessment tools that are available from a single interface. And this is, of course, very comfortable, but also very useful, because it is possible to see the different results of the free risk assessment, so physical attacks, cyber attacks, and natural hazards in the same place. So the user can have a clear picture of the different risk indicators connected to its own plant. And then, of course, we are able and we are actually sharing the information about the infrastructure modeling. So all the data that we ask to the user through the interface are shared with the rest of the partner through the Kafka broker in order to enable also the other partner to use this kind of data in different tools. And I think this will be shown also by engineering in the next presentation. And finally, of course, we are also sharing the results of the risk assessment. So, of course, all the numbers that we have computed within our risk analysis are shared and can be used by the rest of the platform in order to, of course, enhance the amount of data available for the platform. So I hope I made it clear, even if it's always difficult to wrap up the work of several months into a few minutes. If you have questions, I will be available at 5 o'clock for the round table. But if you like, you can also write me an email, of course, in the coming days. So thank you very much for your attention.